Today we're going to look at lesson 6.4, properties of rhombuses, rectangles, and squares. And our objectives today are to define and classify special types of parallelograms and to use the properties of the diagonals of rhombuses and rectangles. So let's look at the solve it activity at the beginning of our lesson. It's been a while since we've looked at one of these, but it deals with folding pieces of paper and seeing what happens with the diagonals in the side. So let's take a look real quick. So it says, what do you notice about the sides and the diagonals of the figure you formed? So we're looking at what do we know about the sides of this figure we have, and what do we recognize about the diagonals? So when it says all four edges line up exactly, well, what does that mean? So all the sides are congruent to that figure. The diagonals cut each other in half. And the diagonals are perpendicular. And each diagonal bisects two angles of the quadrilateral. So this figure with four equal sides, 1, 2, 3, 4, the diagonals get cut in half, which we already have talked about that with parallelograms. The diagonals are perpendicular, make 90 degrees, and each of these angles gets cut in half. So this little half is equal to this little half, and so on. And that's something we're going to explore about the diagonals of this figure with four equal sides. So let's look at some definitions. We're going to define three different special parallelograms today. The first definition is that of a rhombus. A rhombus is a parallelogram with four congruent sides. And a diagram or a picture of a rhombus would look like this. It's a parallelogram that has four equal sides. We're not saying anything about the angles, only sides. The next definition is a rectangle. A rectangle is a parallelogram with four right angles. And a picture of that would be this figure, a parallelogram with four right angles. Now we say nothing about the sides, we talked about the angles. So a rhombus has four equal sides, a rectangle has four right angles. So what do you suppose if we have a figure that has both four right angles and four congruent sides? What do we call that? That's called a square. A square is a parallelogram with four congruent sides and four right angles. And a picture of a square obviously would look like this. All four sides have to be marked congruent, and all four angles have to be marked congruent. So we're going to be looking at pictures of parallelograms and trying to decide what we can call them. How can we classify them? So here's a problem where we're going to classify certain shapes.
In this problem, you will classify special parallelograms. Is parallelogram A, B, C, D a rhombus, a rectangle, or a square? Explain.
Now note that we're after A, B, C, D. There's two of them in there. We'll look at E, F, G, H here in a second.
How do you decide whether parallelogram A, B, C, D is a rhombus, rectangle, or square? Use the definitions of rhombus, rectangle, and square, along with the markings on the figure. You are given that quadrilateral ABCD is a parallelogram. Since angle B is a right angle and opposite angles of a parallelogram are congruent, the degree measure of angle D is 90. Remember, the same side interior angles theorem states that if a transversal intersects two parallel lines, then same side interior angles are supplementary. Angle A and angle D are same side interior angles. And angle B and angle C are same side interior angles. So by the same side interior angles theorem, the degree measure of angle A is 90 and the degree measure of angle C is 90. Since parallelogram ABCD has four right angles, it is a rectangle. You cannot conclude that it is a square because you do not know its side lengths.
Okay, and the next one is EFGH, a rhombus, rectangle, or square. So if we look at EFGH in the picture, we know that EF and EH are congruent to each other. Since it was given that we have a parallelogram, then we know that opposite sides are congruent. So EF would be the same as HG, they're opposite sides, and EH is going to be the same as FG, they're opposite sides, and since they all have one hash mark on them, then all four sides are equal. Now, do we know anything about angles, E, H, G, or F? If we knew they were 90, then not only would we have a four-sided figure with four congruent sides, but then they'd all be 90 degrees. However, we don't know anything about the angles. So all we know here is that the parallelogram is a rhombus. And the answer is A. Opposite sides of a parallelogram are congruent, so all the sides of parallelogram EFGH are congruent, and there are no right angles. Okay, let's take a look at a couple theorems. Theorems 613 and 614 both deal with the diagonals of a rhombus. Let's look at theorem 613. It says, if a parallelogram is a rhombus, then its diagonals are perpendicular. And if we go back to our solve it activity, remember that we had that, when we folded that paper, we had a figure with all four congruent sides. Now, by definition, that's a rhombus. The other thing we noticed were that the diagonals were perpendicular. Let's see that in a picture. So if we have a rhombus and we draw in its diagonals, so I've marked all four sides equal and I've drawn in the diagonals, theorem 613 says then its diagonals are perpendicular. So the trick question is, how many right angles do I have in this picture? And although it appears to be one, we remember a theorem from chapter 2 that says if two lines intersect at one right angle, they actually form four right angles. So the diagonals of a rhombus are perpendicular. That's one of the properties we're going to need to know. The next theorem, theorem 614, also deals with the diagonals of a rhombus, and this says the diagonals bisect each angle. So in other words, each angle of the parallelogram gets cut in half. So if we're given a rhombus, I'll mark it as a rhombus, and we were to draw in the diagonals, 1, 2, it's not a very good one, but this theorem says it bisects each angle. So if this was angle A, then angle A gets cut in half. If this is angle B, it gets cut in half. This is angle C. Now, since A and C were equal, C gets cut in half, and it's going to be the exact same thing as the two little parts of angle A, and the same thing with D. So a quick example might be that if angle C were 100 degrees, find the measure of angle X and find the measure of angle Y. That might be a real quick example. Well, if C is 100, that would be the whole angle, and then A would also be 100, and since the diagonals bisect each angle, half of 100 would be 50 degrees. So x would be 50. If angle C is 100, that makes angle D 80 because they're supplementary. And then half of 80 would be 40 degrees. So that's how we might use the diagonals of a rhombus, knowing they bisect each angle. Let's look at a problem you might see in your homework that's similar to that.
In this problem, you will find angle measures. What are the measures of the numbered angles in rhombus ABCD? How are the numbered angles formed? The angles are formed by diagonals. Use what you know about the diagonals of a rhombus to find the angle measures. The diagonals of a rhombus are perpendicular, so the degree measure of angle 1 is 90. Find the measure of angle 2 by using the alternate interior angles theorem. The degree measure of angle 2 is 58. Each diagonal of a rhombus bisects a pair of opposite angles. So the degree measure of angle 3 is also 58. Finally, use the triangle angle sum theorem. Now simplify to find the measure of angle 4. Subtract 148 from each side. The degree measure of angle 4 is 32.
So real quick review of that. If a parallelogram is a rhombus, we know its diagonals are perpendicular. They cross each other at 90 degrees, and the diagonals bisect each angle. Now that's for rhombuses. Let's take a look at rectangles. The only theorem we have about the diagonals of a rectangle is that if a parallelogram is a rectangle, its diagonals are congruent. So the diagonals are the exact same length. So if we started with a rectangle, and remember a rectangle has to have a right angle, so we'll put one right angle in there. Because if it has one right angle, it's going to have 4 since it's a parallelogram. Its diagonals are congruent. So there's one diagonal of the rectangle, and there's another. So what the theorem says is that if this was triangle A, B, C, D, then the length of B to D, so this diagonal, will be the exact same length, or they'll be congruent to the other diagonal, A, C. So the diagonals of a rectangle are congruent.
In this problem, you will find diagonal lengths. In rectangle RSBF, the length of segment SF is 2 times x plus 15, and the length of segment RB is 5 times x minus 12. What is the length of a diagonal? Your choices are A, 1, B, 9, C, 18, or D, 33. How can you find the length of a diagonal? Since RSBF is a rectangle and its diagonals are congruent, use the expressions to write an equation. You know that the diagonals of the rectangle are congruent, so their lengths are equal. So the length of segment SF equals the length of segment RB. Set the algebraic expressions for the lengths of segments SF and RB equal to each other, and find the value of x. Use the quantity 2 times x plus 15 for segment SF, and use the quantity 5 times x minus 12 for segment RB. Subtract 2 times x from each side. Then add 12 to each side. Finally, divide each side by 3 to isolate the variable. So x equals 9. Now substitute 9 for x in the expression for the length of segment RB. The length of segment RB is 5 times x minus 12. Substitute 9 for x. Now simplify by multiplying. So the length of segment RB is 33. The correct answer is D.
Okay, so that's lesson 6.4, properties of rhombuses, rectangles, and squares. We have used those properties to define and classify special types of parallelograms, and we've used those properties of diagonals, of rhombuses and rectangles. One of the things we're going to talk about in class is going to be why don't we have any properties of the diagonals of squares, and we'll look at that extension tomorrow in class. Now, to finish up the video, I need you to take the quiz over lesson 6.4 that can be found on the Pearson site. Remember, to get to the Pearson site, you'll need to go to My Classroom page and click the Pearson Realize button, which will take you to the login page where you'll log in, and then go to Classes, and you will be able to find that assignment under your class. Good luck on lesson 6.4, and be prepared to talk a little bit more about squares and add those rectangles, rhombuses, and squares to our quadrilateral hierarchy.